Brenton.
Number 2, letter A.
Number 2, letter A.
Is that commutative, not associative?
It is commutative. Now, when we look at number 2, letter A, we see the parentheses, and a lot of times when we see the parentheses, we think it is associative. Associative definitely involves parentheses. But just because there's parentheses does not mean it's associative. If it's associative, the grouping has changed. That's what associative does. It changes the grouping. What is grouped in this parentheses? X and Y. What's grouped in this parentheses? X and Y. We didn't regroup. It's not associative. What did we do? The order changed. And when the order changes, it is commutative of addition. There are 2 commutative properties. One is addition, one is multiply. This is addition. Again, no N in this word. It's not community, it's commutative. Okay, good. What else? Come on, we missed some stuff, folks. We got to get this cleared up.
We went over number 1 yesterday.
Did we do number 1 yesterday? So we're good on that? We have a couple of people got a little bit confused about what number goes on the middle of the number line. This number right here goes in the middle of the number line, right? Whatever makes this a 0, so that would be 4.
If it was like plus in the middle, it would still be.
We make it negative.
Okay.
Yep.
So it's.
When we turn in all of our homework and we request our homework, can we go over like the questions we have on it?
We're absolutely going to do that.
Okay.
Yep. We'll make time to do that. In fact, do you have one right now that's at pressing from P1 to P4, I think?
I do.
You do? All right, let's do a couple of homework questions right now. We can't take the whole period to do homework questions, but let's do a couple of them, just to kind of get us in the book. If you've done some homework and you have a question, give us a section and a problem number. Where is it? Section and problem number. Homework. P4.
Okay, and then number 27, I just confused on how they
P4 27. Graph the linear equation on a graph or choose a viewing window that shows the line intersecting both the X and Y axes. Don't overthink that. 8x plus y equals 40. Is that the equation? 49. Okay. Don't overthink this. You're going to graph this equation on your calculator. Now, obviously, if you're going to put it in your calculator, y has to be by itself. So you're actually going to type negative 8x plus 49? Okay. Now, before you even go to the calculator, stop and think. This is a line. Tell me what you know about this line. It has a y-intercept at 49. So when I set up my window on my calculator, remember, all the window does is tell you how much of the axis you're going to see. If your intercept is clear up at 49, then you're going to want to set your y max bigger than 49. Does that make sense to you? So maybe 60, just so it's not all squished up there. Now, down here, it doesn't matter. I mean, if you want to keep things nice and even, go negative 60. But I really am not concerned about this, or it could be negative 10. Now, what about my y-axis? Well, I don't know exactly what my y-intercept is, or excuse me, my x-intercept, but if I let y be 0, x is going to be about 6. Would you agree with that? About 6. So my x-intercept is out here at a little more than 6, which means when I set up my window, I got to go farther out than 6. So maybe 10. These numbers don't have to match. You don't have to have the same X and the same Y.
So they could vary.
Oh my goodness, yes.
Okay.
There are infinitely many answers to that question. Just Y max has to be bigger than 49 and X max has to be bigger than 6 point whatever.
Okay.
Yes.
So for number one,
Sarah? Is that right? Yeah.
for number one on P4, when you're estimating the slope of the line, how would you do that?
Well, it looks to me like if I extend my line, the blue, in my book, it looks like it stops at about the 0.1, 9. So if I extend it, it's probably gonna go up to about 10. So this line goes up 10 and, actually, over 5. So my slope would be 10/5, but it's negative because it's going down. So if I go from the point 0, 10 to the point 5, 0, I'm gonna count down 10 and over 5. So it's about -2. But again, I'm estimating, so, you know, if you said a little bit different than that, it would be okay. It's hard when they don't, like they didn't actually give us any little boxes, weird boxes, so we're kind of really estimating.
Can we do 51 on P4, please?
P4, 51. All right, now P4, 51, problem 51 is a problem that I could, if I had the different directions, I could type all those data points into my calculator. But I don't need to do that because they tell me I'm using the points 1998, 5.9, and 1999, 6.3. And they say write the equation of or write a linear equation. Okay, what does that mean? Write the equation of the line. So what do I need to write the equation of a line? The slope. No matter how you're doing it, you gotta have the slope. So the slope is gonna be 6.3 minus 5.9 over 1, which is, what is that, 0.4? So my slope is 0.4 if I did my arithmetic right. And then you can write the equation of the line any way you want. So if you use this strategy, pick a point, 5.9 equals 0.4 times 1998 plus B. Time to break out the trusty calculator. So negative 793.3 is my B value. So my equation of my line is 0.4x minus 793.3. Okay, Rachel, does that make sense to you?
Yeah.
That much of it? Okay. So then use the equation to estimate the expenditures in 2002. So if I use my equation to approximate the expenditures in 2002, what am I going to do with the 2002? I'm going to put that into my equation. Is it going to go in as X or Y? X, because that's the way your ordered pairs were set up. They were set up year, comma, whatever that is, money or whatever, right? So I'm going to take my equation and I'm just going to put in 2002 for the X value and type that in, thank you, and type that into my calculator and figure it out. Here's your quiz for you. Thank you. We're doing homework questions right now, but we're almost done with that. Okay, you work that out, okay, Rachel? With me? All right. Then it says do it in 2006. Same thing, just put 2006 in there. Then it says superimpose a graph of a linear equation on top of the scatter plot. All right, so now we're going to build the scatter plot like we did yesterday, remember? Stat plot.
Yeah.
You're going to put these numbers into your calculator, stat plot, and there it comes. Now, at the same time, you've got that scatter plot going, in your regular y equals menu, and just the button that just says y equals, you have a button on a calculator that says y equals, put this equation in 2, and it will graph both. It will graph that equation, and it will graph your scatter plot. And hopefully, you're gonna have a situation like this, where the line is like right in the middle of all of those points, okay? All right, we'll do one more homework question, and then we've got to move on. So who else has a homework question, something you've discovered as you've been doing your homework? Yep. P2. 19 on P2. 19 on P2. I did that in class.
Yeah, you did.
Check your notes. I did that one in class, yeah.
Number 36 on P2.
Okay, last one, number 36 on P2. Oh, great question, Max. Great question. This is a review question. I did not mention it at the time. This whole idea of percent increase or decrease. You did these in first year algebra. When you went to the grocery store and you paid tax on something, or you bought a new shirt and it had tax and a discount and all that stuff. To find the percent of increase or decrease, anybody remember? Percent of increase or decrease, how you find that? It's the change over the original. So in this case, if we're doing 36A, we'll just do A, they're all exactly the same, Max. Is that okay if we just do A?
Yeah.
So we're going from January of 1996, which has a value of about 142. It looks like it's about 142. And then 1997 has a value of about 181. The change is whatever these two minus each other are, and the original value is 142, because we went from 1996 to 1997. So my answer would be, okay, what is that? Is that 39? Divided by 142. So I'll put that in my calculator and get a decimal, and that will tell me what my percent increase is. Now, yours might be a little bit different, because remember, I approximated these numbers from the graph. So you may have 143 and 182 or something, I don't know. But it should be close to, I got 27.46%. And that would be an increase because it went up. My values went up. But that's how you always find percent increase or decrease. You take the change divided by the original. Okay? All right. Well, as you're doing your homework, mark the ones you have questions on so that when we have time like this, we can grab them and get some of them done. If you have not yet started your homework, please do that over the weekend. Please do that. There's a lot of it there, and if you do a little bit every day, it's not going to kill you. But if you wait till the night before, oh my goodness gracious, I don't think it's even possible to get it all done. All right, today we are going to talk about quadratic equations. Who knows what I'm talking about when I say quadratic equations? Okay, now that's the quadratic formula. Let's go ahead and write it down. She said what pops into her head is x equals negative b
Plus or minus the square root of c squared.
b squared
Or ac
or
over
ac.
2.
Perfect. And this is called the Quadratic Formula. And it's one of those things we just need to know if we're an educated person. So there you go. You're all educated people, so you're going to know this if you don't already. What is this A, B, and C stuff? What's that? What do we mean by the A and the B and the C? What are those, Dylan?
The quadratic formula, doesn't it go a squared plus b squared plus c equals?
That is a quadratic equation. If I say the word quadratic to you, you should automatically think squared. Linear means plain x. Quadratic means x squared. When we graph lines, or linear equations, we get lines. What do we get when we graph a quadratic equation? A parabola. Yep, these are going to graph as parabolas. Okay, so if your job is to solve a quadratic equation, one option that you have, let's just make one up. One option that you have is to use the formula, right? And the nice thing about the quadratic formula is it will always work. Okay, always. So if you're walking down the hall and you find a quadratic equation that needs solved, this will do it for you every time. A is 2, B is -8, C is -1. Here we go. X equals. Watch it now. B is already negative, so this will be 8. Right? B squared minus 4AC, watch your negatives, all over 2A. Be careful with your arithmetic. What's underneath there? 64. Actually, it'll be plus 8.
Oh, yeah, plus
Square root of 73. 2. It's 8, so it'd be 2, wouldn't it? Now, do you see that 4 and that 8? Somebody's going to try to cancel those, and I'm going to write some kind of smart aleck comment on your paper. You cannot cancel these, okay? You can't, when you have a plus or a minus, you can't cancel parts of that. It's like having x plus y over x. It doesn't make sense to you to cancel those, does it? No, you can't. So, are we done? Is this what you would put in the answer blank? Are we finished? No, because we've got a 72 here, which I bet breaks down 6 root 2. You've already done it. And for those of you that are saying, what? Stop and think. This is 36 times 2. And the square root of 36 is 6. Now can I simplify? Yes, because now I can cancel out of all 3 parts. It's like factoring a 2 out of the numerator and canceling that 2 with the denominator. If you can factor it out, you can cancel it out. Now, I still have a 2 and a 4, but I am done canceling because 2 does not go into 3 evenly. So that's my answer. I wish that we could just do the quadratic formula and be done with it. But unfortunately, there is a need to know a couple other strategies. A future need for you as a pre-calculus student to know a couple of other strategies. So does anybody remember either one of those other strategies to solving quadratic equations? Well, when you were little, I'm talking like 8th grade or something, whenever you first started doing this, you didn't jump in with the quadratic formula. The first time you saw quadratic equations, what did you do with them? You factored them, absolutely. I am not a huge fan of factoring. I had a terrible first year algebra teacher, truly I did. I mean, she's a wonderful woman, but oh my, it was bad. And I just never felt comfortable with factoring. But unfortunately, it's a fact of life for a mathematician. So we could solve this by factoring. Does that look okay to everybody? And then that means my answers are 5 and -1. If you ever do your quadratic formula and you end up with answers like this, for example, if this hadn't been a 72, if this had been a 36, then you would have had 8 plus or minus 6 over 4. See how there's no more radical? You would actually get numbers there. 8 plus 6 is 14 over 4. 8 minus 6 over 4 is 1/2. That means the problem factored. If your answers come out like this with no radicals, it means you could have factored it to start with. Sometimes we have to factor. All right? There's another method that sometimes we have to use. Does anybody remember what that is? Michael? Oh, now that is another method. I wasn't thinking about that one. It is. And so, if you want to graph on your calculator, what you would be looking for, if you were going to solve this on your calculator, what you would be looking for is where it crosses the x-axis. Just like before, you'd be looking for where it crosses the x-axis. Graphing is always an option for any kind of equation if you have a calculator and are allowed to use it. Okay? Yes, I had thought about that. Thank you, Michael. What's another algebraic method? Completing the square. Oh, and I saw somebody's face go, I'm with you. I don't care for it either, but we got to know how to do it. So let's recall how completing the square works. Don't moan, you can do it. 2x squared, let's say minus 8x. No, let's not use 8, let's use 12. Plus 2 equals 0. All right, we're going to solve this. And we're going to solve it by completing the square. The first thing that has to happen if you're completing the square is that this number right here has to be a 1. So if your equation looks like this, you're good to go. If it has a coefficient here, you got to divide it out. The second thing that has to happen is this number's got to be moved to the other side. Because, as you recall, hopefully, now that we're doing it, maybe ringing some bells here, you're going to add something to both sides. Do you remember that?
You divide the middle by 2.
You divide the middle by 2 and square it. Do you remember that? Very good. You divide this by 2, so you get 3, and you square it and get 9. So you move this number over to make room for your new number. The reason that it's called completing the square is because now this should be something squared. The x minus 3. And if that's confusing to you, factor it, and the two factors should be the same.
Wait, you take the middle number by half and then square it,
Mhm.
correct?
Yep, the middle, half the middle number squared. And then that equals 8. Okay, what do we do at this point now? Square root both sides. And here comes the part we sometimes forget. When we take the square root of 8, it is plus or minus. Remember, quadratic equations have 2 answers. In order to get 2 answers, you have to remember the plus or minus over here. What happens when we square root a square?
Just becomes x.
They cancel, right? They're opposites, inverses of each other. So we have x minus 3 equals plus or minus, I'll go ahead and say 2 root 2, is that okay? Square root of 8. So x equals 3 plus or minus 2 root 2 if I add my 3 to the other side. All right, try one with your partner real quick. We'll do one more completing the square, then I have one more thing I want to touch base with you on. So do this one with your friend. How about this? Negative 3x squared minus 12x plus 6.
You can't really figure it out.
I want you to complete the square. I want you to practice completing the square. Yes,
So you don't
Jade?
want us to go any farther on that one? Is that good?
This is the answer. What else would you do, Angel?
I don't really know.
Nothing. That's why you don't know. There's nothing else to do. You are done at that point.
4x plus 2.
Because it's -6. Oh, that'd be
Okay, write these down and complete the square. Compare notes with your neighbor.
We can find it out now.
Complete the square.
And then what you're gonna do, you take 5 by 2, which is 2, square that, which is 4, so plus 4, plus 4.
X equals 2 plus or minus 6.
Jack, put your hand up.
Is that negative?
I should do that. Thank you.
Does he even know it's his birthday? I went to the birthday.
Okay, let's talk about this. How do you do it? Remember, if you are completing the square, and this is really an important step. So try to remember, if you're going to complete the square, you cannot have a number here. That number has to be gone. So the first thing I did was divide everything by -3. Are you with me on that? And then I moved my 2 to the other side. Then I took half of 4 and squared it and add 4 to both sides. This was then a perfect square, and that was 6. So I took the square root of both sides, plus or minus on the 6, and moved my 2 to the other side. -2 plus or minus root 6. What do you think about that? Okay, now I want to talk about a couple of problems that are in your homework. If you had a problem that looked like this, this was the problem was written this way, how would you solve that? You'd square root both sides, wouldn't you? And it would be just like this situation. What if the problem looked like this? Could you do the same thing if you divided both sides by the 3 first? So you'd have 7x minus 1 squared equal to 13/3. And then you would square root both sides. So you'd have 7x minus 1 equals plus or minus root 13/3. Now we have some arithmetic to do. This is kind of a mess. We have some arithmetic to do, but you are essentially done. We just now need to get x by itself. We have a little bit of an issue here. Root 13/3 is the same as root 13 over root 3, correct? And we've got this rule that says no radicals in the denominator. So do you remember how to do that? Multiply it by root 3, so we'd have root 39 over 3, correct? Are you going to cancel 3 into 39? No, because you can't cancel a number that's not in a radical with a number that is in a radical. It's not fair. You can't do it. So we're stuck with that. All right, so we have 7x minus 1 equals plus or minus root 39 over 3. All right, so we'll add 1. You okay so far? It's ugly. Now we're going to divide by 7, but here's the issue. If you literally divide by 7, you are going to have a mess that you're going to have to clean up because you're not allowed to have a little fraction inside of a big fraction. So let me suggest that instead of dividing by 7, you do what?
Times 1/7.
Times by 1/7. Because if you do that, then you don't have that problem. You have 1/7 plus or minus root 39 over 21. They sneak a couple of these bad arithmetic situations into the homework. Just do it like you've been doing it, but take care of the arithmetic as you go. And if you have to divide by a fraction, we're not done. Quit watching the clock, you guys. I used to have a sign hanging by my clock that said, "Time will pass, will you?" But then some administrator decided that that wasn't very self-esteem building, so I had to take it down. But it is true. Time will pass, whether you're watching it or not. So just forget about it. We'll go when it's time to go. Anyway, I forgot what I was saying, but something about take care of your arithmetic. Don't panic. Just do it. It'll be fine. Okay? Now, once in a while, when we do one of these problems, something happens that's a little bit disconcerting. Let's solve this one. And I don't care how you solve it. Solve it any way you want. Complete the square. Ooh, I probably wouldn't complete the square. Because why? I'm going to take half of 5 and square it, and that's not going to be something I can easily do. So I think I'll just use the quadratic formula. Oh, by the way, it does not factor, does it? So I think the formula is probably the best way. So here we go. Now this is what's a little bit crazy. What's going to be under here? -3. Now when you were a little kid, they told you couldn't take the square root of a negative number. But then last year, your teacher opened up this whole new world for you, right? How do I handle the square root of a negative number? This I is the square root of -1. So when you have a -1, this is like -1 times 3 under there. If you have a square root of a negative, you're going to take that and rewrite it as an I. Do you remember that from last year? Just like before, nothing here reduces, but if you end up with something like -4 plus or minus 2i root 3 over 6, you can cancel here, here, and here. So it's just like what we talked about before in terms of canceling. This one does not reduce. This would be the answer. Now, what if Michael says, wait, Miss Ford, I want to graph this on my calculator. Any ideas what's going to happen when he graphs that on his calculator? Actually, it'll graph. It'll graph for you, but what won't it do?
It won't find the zero.
It won't cross the x-axis. You'll have a parabola that's like up here, which tells you that there are no real zeros, because real zeros will be x-intercepts. And if you don't have any real zeros, you're not crossing the x-axis anywhere. Does that make sense to you? Okay. All right. You should be able to, at this point in time, you should have done all, you can potentially have done all of the homeworks through P5. That's through P5. Actually, yeah, through P5. Okay? So, have a good weekend. And here we go.
So beautiful.
No, I'm drinking a ton of water. What happened last week?
Love you, thank you. Have a good weekend. Be safe and smart. Where's my girl who has to make up the quiz? Me. Yep, all right. Bye, Sarah. Bye. Bye, honey. Have a good weekend. You too, Angel. Bye. We have a game this weekend? No, it's not this weekend. Okay, bye, honey. Try to get class on time, Clark. Okay, bye.
See ya.
When is your lunch period?
It's like next period sometime, obviously, but I don't know.
Okay, what subject are you in? You may know in science.
Oh, never mind. I don't want to tell you wrong, but I feel like I think we're second, but I don't want to get that out.
Okay, you can swing by here if I'm in here, yes, but I'm not gonna sit here all period, because I gotta go meet with the counselors, okay? So if I'm in here, otherwise I'll see you before school on Monday, okay? Yeah. Yeah. You know what? There should be, but I don't know how to get it, so you're gonna do everything in L2 and L3, it'll be fine. It'll be fine.
Because I tried it yesterday and then I wanted to put it in, but for some reason it's just like an error.
Well, let's just. Run that. Oh, there, I must have been pushing on that, so let's just put in some data points, there's the data. your handbook out. Alright, let's do this. Let's clear. I don't think we have an L1, but just in case you do, let's clear it. Now let's grab. Okay, let's check dimension this. Oh dear! Check inverse of square matrix only.